AI technology isn't just making our lives easier. Unique decisions to machine raises concern over data privacy. So is AI the cure to healthcare toughest challenges? Dr. John Langford. Dr. Langford has held influential research positions at Yahoo.
Machine learning offered a potential path to doing those things.
What has happened in the last 35 plus years?
And I think one of the keys here is just the quantity of internet data around language.
From the way we shop online to how doctors detect diseases, AI and machine learning are already shaping our everyday lives, often in ways we don't even notice. Every time your phone predicts the next word you'll type, recommends a series you love, or helps your smartwatch monitor your heart rate. It's machine learning, quietly, silently working behind the scenes. But this powerful AI technology isn't just making our lives easier. It's actually transforming medicine. It's transforming work and societies in ways that are both exciting and unsettling. On the brighter side, AI is saving lives. Groundbreaking research showed that machine learning models dramatically improve early disease diagnosis, diagnosing conditions like cancer and sepsis faster and more accurately than traditional methods and humans. A study published on PubMed. But for all its potentials, AI's rapid rise isn't without serious consequences. Research has shown that the algorithm bias, often hidden in training data, can worsen healthcare inequities, can misdiagnose underrepresented groups, and may even reinforce other agendas. Moreover, handling unique decisions to machine raises concern over data privacy, as patients' information used to train AI can be exposed or misused, can create ethical and legal risks. So is AI the cure to healthcare toughest challenges, or a technology that could deepen the very problems it promises to solve? So today's episode isn't just about celebrating technology, it's also about asking the tough questions. How do we build AI we can trust? How do we ensure fairness, transparency, and accountability? Welcome to another thought-provoking episode of Khan Clinics. I'm your host, Dr. Amir Khan, and today we're joined truly by one of the most influential minds in the world of artificial intelligence, Dr. John Langford. He's born in States, is a leading figure in the field of machine learning and artificial intelligence. He's currently serving as a partner researcher at Microsoft Research in New York City. Over the course of his career, Dr. Langford has held influential research positions at Yahoo Research, Toyota Technologies at Chicago, and IBM's Watson Research Center. He's widely recognized as the creator and primary developer of Opal Robot and is known for his pioneering work on reinforcing machine learning. Dr. Langford, we warmly welcome you to Calm Clinics.
Thank you.
Let's start off with the first question, John. You study both physics and computer science. What drew you into the world of machine learning?
It was a class at Caltech. Yasser Abu Mustafa was teaching a class on machine learning. And it was just, I don't know, I really enjoyed it. It was like, I think I want to do this. It seems exciting. It seems interesting.
And whenabouts was this class that you took that drew you into going into a field which is you were probably already exposed to, but now you're trying to tie the knot between the physics, computer science, AI, machine learning, and other stuff?
It would have been about 1995, I think.
It's probably at a time when a lot of people didn't understand the machine learning concepts.
Yeah.
What did you find intriguing about it at that time? What drew you in? Was there anything specific? You saw a vision you were going to change a lot of things in it? Or was it just a gut feeling that this is what I want to do?
I mean, in the end, it's always a gut feeling, but there were certain aspects which really drew me in. But there were many things that you couldn't program very well,
Hmm.
and machine learning offered a potential path to doing those things. Right, so recognizing things in photos was completely impossible back then. Nowadays, it's actually pretty common and easy, and that's machine learning.
So, say it's 1985, fast forward 2025, and looking at what has happened in the last 35 plus years. Do you think we've made good, reasonable strides? Could we have got here faster? Or do you think we're going on a good pace, considering what's happening now, a sudden boom in machine learning, AI talk, and everything, and its applications, especially in the last, I would say, last 2 5 years, a big boost?
Yeah. So it's only 95, so it's only 30 years, I guess. But in terms of could we have gone faster, I think the answer is always yes. But I think there were certain technological trends that needed to mature in order for machine learning to really bloom. So the amount of compute used to train modern machine learning models just simply was not available for much of that 30 years. So reaching the point where that's just the raw compute is sort of the most obvious thing. There's also kind of the data side of this. I think the amount of data that you use to train with has grown a great deal, dramatically. So that sort of room to get a lot of data, and then then there's kind of the algorithm side, and that's where the machine learning research is typically playing. And what you see as you look there is that as people have been able to use GPUs and as people have been able to use larger quantities of data, the ways to do this have come along in the research. Right, so you really needed to have sort of those enabling GPU compute and enabling internet scale data in order to get the really big surprises. To be clear, there were useful things that machine learning could do before then. A good one is Jan LeCun had this convolutional neural networks, which were used for recognizing zip codes by the post office. Helpful, kind of helps automate some of the mail sorting, but that's sort of like a pretty limited application compared to what we see nowadays. Nowadays, you can't interact with a computer without interacting with some machine learning system.
Fantastic. It's really nice. I'm saying this when we're hearing it from you, because you've really actually taken this journey and been at the forefront of all of these transitions and changes. So it's very exciting for our viewers listening to what you've been through. And in particular, I have a fan in my office as well. He studied a lot of things and he's very excited about this meeting. You worked at places, for example, Yahoo, IBM, and now at Microsoft. You've been seeing these transitions and changes as they've evolved. What's the most surprising thing that you think you've learned along the way and help you grow?
I have been surprised, although not often. Just the general progression has surprised me structurally. And there's a particular technique which has surprised me in terms of its capability. So the general progression that I expected was more like the evolutionary path of life, right? So you have plants that can do almost nothing, but we have wisteria in my house, and it can actually twine around things. And then you have worms, and then you have flies, and then you have reptiles and fish, and then you have mammals and birds. And so you increasing capabilities as you go up. And so I was expecting that what we would see is a progression of capabilities in that order. And that's not actually what we see. Robotics is not solved anywhere near. Chat agents are actually amazingly good. And so that out of order surprised me. That's maybe one thing. And I think one of the keys here is just the quantity of internet data around language, and the fact that language is a very semantic thing ends up being very helpful for these algorithms. And then the key technology which surprised me is transformer models, which is the underlying thing for these large language models, the underlying architecture.
Thank you for explaining that. John, let me go on to two of your the innovations that you were involved in. One was the CAPTCHA, and for my viewers, this is a system or a program that distinguishes between humans from machine learning input. Typically, it's used as a spam mechanism and auto detects it. And you were one of the instrumental, you and your colleagues were involved in coming up with this idea and implementing this and for internet safety. One was CAPTCHA. And then the other one you were very actively involved in was the machine learning system, Vopal Wobbit, an open source, fast online interactive machine learning system as well, and a library. What made you come up with these ideas with your friends? What a remarkable journey we've just experienced together. The path to health isn't always straight, but it's always worth the effort. I hope today's conversation inspired you to take the next step in your wellness journey, armed with new knowledge and a fresh perspective. If today's episode left you inspired, share it with people, someone who need to hear this. Give us a thumbs up and your opinion. Keep exploring, keep evolving, and we'll see you in the next episode of Khan Clinics.